Today there are many softwares available for modeling of power converters, and these power converters are very today in every sphere of life. You will find that there is a use of power converter, starting from a simple motor control, your fan control, to a gigantic driver of traction motors. So this Simulink, the modeling and control is required for all kind of the devices. So the Simulink, the dynamical modeling from basic, actually we will start. Generally in power electronics, there are many softwares which is available today also in the market. And many of you can, you know that these softwares are very useful for modeling. Because why? The modeling is the important factor, because to know the dynamic of the system. For example, if you want to uh, design a traction motor, so you bring a traction motor and connect it to an inverter and control it. And if some uh, problem comes, then you will always see that, oh, this because of something it is not working. But when you study this one, if the feasibility of the system you can understand, then you can implement. That's you can save a lot of cost and damage to the circuit also. That is why the dynamic system simulation is one of the very important topics. So in this course, in this special class, we will study the Simulink in the dynamical modeling, and simple models we will take, and then we will simulate, and a few examples we will take. So for power electronics, if you see here, there are many such softwares are available. You see Spice, MATLAB, Saber. Saber I used to use during my master's, and after that license is over, so we could not able to do. Cashbook and PS Card, these are the few software. There are also few software also available today. There are many softwares are available, and these Saber, EMTP and Spice, and these circuits, this simulation are, and this they required less effort because you have a model. For example, you require a switch IGBT, you bring it, put it, it is very easy. Okay, there is no need to understand why, how that MOSFET is designed. But you know that the MOSFET is available, you put in that. But the problem is with this one, although less effort, sometimes you have not simulated, because you have not simulated the circuit. That is why the internal dynamics always it will become very difficult for us to understand. So to study that internal dynamic, these softwares are failed. And Simnon and MATLAB Simulink, and MATLAB today is very, it is, I have designed for, you can see that MATLAB 6.5, and now MATLAB, I think 12 already it came, I think. So already 12 generation is over, okay. So this, the Simulink is a program that runs as a companion to MATLAB, and there are graphical interface where you can easily understand. So when the MATLAB in the code, we sometimes we design in code like C language. So you write a code and run the program. After running the program, then you save the program. Okay. So when you save those programs, then you run that one, debug it. Exactly, you can write a code. But in MATLAB, The matrix laboratories are available where easily you can do. As many line program in a MATLAB is only one line program. So that is why MATLAB is very easier for handling, because the library is already available to you and it is very easily you can do that one. So in MATLAB, I remember when we used to design an induction motor model and we will try to run that program, it used to take 2 days for running one program in MATLAB in those period, because the processor speed was not there and we are not very efficient programmer. So I used to do, and it used to take 2 days just to give the response of a induction motor. Whereas today, within a fraction of second, you will get the result. That is what today is very sophisticated things. And that is why that is not good for us, because after 2 days you get result, if not proper result, again you go back like that. Then Simulink is a model in Simulink model, and this is you can take the parameter, for example, induction motor. Already induction motor is available, and this induction motor, when you take that induction motor and use in your circuit, you may not get same performance as you are. That is why, because internal dynamic of the system we do not know. We just took that model and put it. That's why if you go to IISc Bangalore and IIT Kanpur, here also I never encourage students to use model. I tell the students, you write the equation, from the equation you develop your own model. And that way, this becomes very easier. Okay? And there, there are, if the Simulink plus MATLAB is the best choice. And MATLAB, you can initialize all the parameter in M file, and then you design in the Simulink, and then you run that one. It is all the parameter variables you defined in the Simulink, they will take the parameter from M. So this way, it will be very easily this complete unit can be designed with very less complicated thing. So if you see here, there are available toolboxes. Okay, nowadays there are a lot of toolboxes are available where you can, in the latest model of Simulink, you have all kind of modeling is there. So the Simulink is one of the modeling in this. So in the Simulink, there are many things. There are sim mechanics, Simulink extra, state flow, everything. And there is a sim power system which connected with the power engineers. Okay, here you will get power system, power electronics component there, all machines, everything. So like that, when you see in the MATLAB, there is a button here called the Simulink. When you click here, or you can write, just you write Simulink and enter, you will get this. Okay, so when you enter this one, so the Simulink will come, and the Simulink blocks, you can see that from here, all these different block sets are available in Simulink, and these block sets are connected. You can see that here continuous, discontinuous, all these functions are available in the Simulink. And source means you can have all kind of sources are available. Sync is nothing but your different kind of loads. So there are equation based modeling and model based modeling. In model based modeling, source means you take a directly AC source or DC source or current dependent source, dependent current source, dependent voltage source. Okay. So like that, you will get model based. You will get directly the model, and take this component and design your model and get the result. So this is very easy. Okay. And equation based model, you need to derive all the equations, and from those equations you will develop the model, which is a little tedious, but it is very good actually. First thing is you can see that here Simulink source file. In the source you see signal generator, pulse generator, all these things are available. And in the sync you can see terminated, output, scope, everything is available. And then discrete stage means when you use digital controller. When you are designing a controller, you apply a small time delay in the feedback as one microprocessor or microcontroller. If the A to D converters are available, you will see that they are taking lot of time for around 1.6 microsecond for converting from analog to digital. So these discrete blocks are very important in that one. And then there is continuous libraries, well, like transfer functions are available, or state space models also available. These are called the continuous. And then MATLAB. Then there are signal and routing, like mux. You want to many into one and one into many. So like that. And then selectors, multi-port switch, everything is available in the signal routing. So like that, the model based also similarly, you can see here the electrical machines. All kind of machine, permanent magnet machine, induction machine, all the machines are available here. Permanent magnet, synchronous generator, motor, both are available here. So similarly, the connectors also, the grounding and power connector. This is connector means not an ordinary connector. This is a power connector. Okay. So connector in that box, and this is different. Okay. This is a bus structure, bus, and that is a small signal level, like in power electronics. We studied that there is a power circuit and there is a control circuit. And the power circuit handles hundreds of the voltage. Control circuit is only few, is very less voltage. Okay. So this way, this uh, uh, this is the like that. There are measurement, voltage, current, power, all measurement is available. So now if you see, this is a Simulink, and you can open a window and you can have a Simulink window. Now in this window, you first need to choose this which solver you want to use. Before simulation start, you need to understand what is the solvers. I think all of you must have studied Euler's and all kind of Newton-Raphson methods or trapezoidal methods. Okay, there are many solvers. Time step and continuous or discrete. These three you need to define. You see, this is as our the first time when we used to get the data acquisition board like this. Okay, this is a PCL 208 board. Okay, so PCL 208 board, and this board we used to get, and this board we used to connect here. You can see the computer system was open at this point, and we fixed this one here. And this is a computer, you can see that very old computer. And this is connected to here, and this PCI slot, we put it. Okay, there are ASI and PCI slots. If you study at least the instruments, there you will understand what is a PCI and a ASI. Okay. So according to Princeton architecture, that is PCI slot was developed, and according to industry standards that ASI was developed. Okay. So this programming, you can see that here, the programming is just a fraction part of the program. So you can see that this programming having hundreds of lines program just to study a simple A to D converter and a big line of program you need to design. So that is nowadays it is not required. You can see that this is the control board is connected to this converter controls, and this is supplying the voltage to your induction motor. So this was the initial days. And you see, sir, that such a huge programming is solved in very few lines of program in MATLAB Simulink. So this is the Simulink model, and it's the Simulink model how to solve. So there are fixed step, variable step, fixed step discrete solver, variable step discrete solver. So this fixed time, there are OD1 Euler's method and improved Euler's method. All these things are already available in the literature, and I think all of you must have studied. We use this in the when we have a hardware. So we use Euler's first order method. And when for our programming we use OD4 or OD3, like this type of solvers. So after choosing the solvers, then we have fixed discrete variable continuous, so variable step discrete solver. So these are the different kind of solving methodology, and these methodologies can be applied here. For example, here in this one there are three: normal, external, faster. Okay. So now if you want to integrate, so you will get an integrator. You put here, it will integrate the signal. For example, I have taken this integrator, and when you click on the integrator, you will see all these parameters inside parameter, where you can put the initial condition and then upper limit and lower limit also. And like that, it can be applied. So if you want to know about integrator, you go to help. You will get all the detail about integrator. For example, here you are seeing that there is a sine wave input, and just I integrated and I got this waveform. So you can see that a simple integrator, this sine wave is integrated, and you can see that both are here. So in this scope also you can choose number of axes. You want to see 4, 5 also, 10 also, you can just change number of axes, it will change. Okay. And data limit point means only 5,000 sampling values will be stored. So if you remove this this place, there is a tick. Tick means 5,000 data should be saved. So if you remove this tick, so you can choose all the data can be saved in this workspace. And how it will save? You can save as an array, structure with time, all kind of way data you can save. So this one is this initial step. Then another, creating a model. You see, this is a model. And what is this model? This is a unit delay. Okay, 1 by Z. You will get in discrete. And 1. You see, you run it, this program, you will see this is go on increasing. So it is like a unit step. Okay, this is like a counter. 1, 2, 3, 4, 5, 6, like that. It will go on counting. Okay, this is simple model. And if you want to make this complicated big system into one, Just you choose this one and put Control G. When you put Control G, it will become a group. That complete unit is within this one. So you have an input and output. All the circuits are within that one. So that this whole big program can be, you can make a small segment, okay, some model of this program. So we'll take a simple equation, okay, second order equation, that mx double dot, okay, here mx double dot plus cx dot plus kx is cz dot and k. And this is a mass spring system, okay. So what we will do first, when you have a like this second order equation, first you take the highest order in the system, this part, in one side, all other you bring other side. Okay, that is our first step. That the highest order you bring to one place and all other to other place. So then this I made, you can see that the same equation is transformed into a this equation. So x double dot is minus c by m. The, just I shifted to the one side only. And then this equation, you want to model this one. Now you have x dot, x double dot. If you integrate first time, then you get x dot. Again you integrate, you get x. So this entire system is model. And then two integrators are connected in series. And this x dot and these two are taken two integrator. And after two integrator, then you required here, you can see that in this circuit, you can see here that this x dot is nothing but this is multiplied, this x dot, you are here. Okay. This is x dot. Okay. And then x is this one. Then what it should multiply? X dot should be multiplied by the constant here. And that is constant here. And the x is multiplied by this one. And this is multiplied here. And when you multiply this one, this entire equation is over. Now we have this much. All these equations are available here. Okay, sorry. Maybe I will remove this one and put some other color. Maybe you will. So we have all these equations we have now simulated here. This part is simulated with this equation. So as this part is over, now it remains this part. Okay, this portion is remaining. And then connecting everything. So when you go, this is the another part of that system we made. And then the complete unit is simulated here. So the x dot is nothing but 2 integrated, then this is your minus, minus, plus, plus. Okay. And you can see that the parameters m, k, c, a, and f is defined in the MATLAB, then in the workspace, and then you will get here all the parameter in this one. And then initialization of the variable came, and then you design your Simulink model. There's maybe a constant or maybe sinusoidal input, and this is the complete unit what we have already discussed here. This is your output the unit, and this is your input unit, and then complete thing you can see in this scope. So these two systems are modeled, and this modeling, after modeling, so you need to you know that these are the parameters. It is available in the workspace. And then you run this one. There is a button here. When you run this one, you can see in the scope like this. And when you click on the scope, you will see that this is your output. So this is a simple system. And now we will go to model a electrical system. You see, this is a electrical network. And this electrical network is nothing but a electrical simple a loop, two loop equation, okay, two loop with transients. So the parameters are given here, LP, LS, all these parameters are given here. And step input simulation, you need to simulate. So if you want to simulate, you can do, we will do in three methods what we have already discussed. One is with MATLAB coding, and then MATLAB with Simulink. Third one is MATLAB plus Simulink. So with a power system. So we have defined all the parameter here, and after defining this one, then we design the programming. Okay, after, so you can see that these are the current and this is the voltage. And then these are the parameters what we discussed. Again, you can use a simple Simulink block equations for defining. So this is the one equation. A, B, C, D already defined here. What is A, what is B, what is C. So this will bring at this point, and then we give to the output. So this here also you can see that here also the same kind of result. And also you can take the parameter L and C, everything, and design the circuit. You will get the similar kind of thing. That is why whatever way you do modeling, you will get the same response. So there are PWM switching, like I have already discussed in the inverter circuits. So PWM is sinusoidal pulse width modulation. There are three sine waves, and compared with a triangular wave, accordingly you can switch on and switch off. So this how to model this. So you can see here, this is the thing that when upper switch is on, let's take plus one. When the lower switch is on, let's take minus one. So here you can see that in this one triangular wave is compared to three sine wave, and one sine wave is sine omega t. Another one is sine omega t minus 2 pi by 3, and another one sine omega t plus 2 pi by 3. These three signal are compared and the output is given, and this will go to your switching converter circuit. So this is compared, and the output is, you can see that this is a switching control. So switching control means when the output voltage is greater than some value, you turn on the, so like that. So if the reference is greater than the triangular value, then you get 1. If the else, you get minus 1. So this is what the logic. This is the output signal. And this is the universal bridge, okay, by using Simulink. Directly you can take 4 diodes and a transformer, and you can connect a filter, and it is connected to the load. So similarly, single phase rectifiers, there are many demos also available, and you can go through that demos. So this is our dynamic model in the, this is a dynamic model of AC motors. And this dynamic model are completely, you can see that the state space model is completely put in these equations, and this is the complete model of induction motor. Although the induction, each block you see very complicated one, but still this is one of the block, and this is the one block, this is another block, this is another block. So each block you can see that it is very complicated, and this each block is modeled in this way. And there are many like this also, you can complicated system you can model. So this way we can model different power electronics converters. Okay, when we connect like this power electronics converter with this modeling will help us how to do this one. So whatever examples I have shown you here, you can see that there are this is are the Simulink models of this PW inverter and Simulink model of the Boolean Simulink model and a very complicated unit also you can model. Okay, so this complete circuit I have modeled. You can see that there is a 3 level. I will tell you maybe some class later what is 3 level converters. These are called the multi-level converter. 3 level converter and 2 converter back to back are connected here, and this is for grid connection. This is for the connecting to the motor. So the complete control unit is implemented, and this unit is after implementation. This is AC DC converter, and first we implemented AC to DC converter front end, and second we this one is your first AC DC. This is AC to DC. Okay, and this is from DC to AC. So this system is simulated, and these are the simulation of the load side converter or the, and this is front end and this is right end. If you go inside, all the parameters everything are there. So this is the inside of the front end converter, and this is inside of the induction motor side converter. So it is very complicated, but you can model it. It is not very difficult. So anyway, these are the different system model you can design, and this is the complete model is designed, and these are the hardware. And this after modeling, you can see that the complete hardware of a traction motor. If you go inside a train, okay, in a traction, you see that this is a one converter circuit, multi-level converter fed from this transformer through this capacitor to this converter. Okay, like this. And from here, there is a connection to this converter circuit here. And then from here, you get the output torque, okay, which is controlling this induction motor here. This is connected through this one, you can see. And these are the controlling motors, okay, loading motors. And you can see that the switching signal flows from here. For this switching signal is flows from here. So two converter control is very, very complicated. And all kind of train drive will have like this converters. So these two converter also model very nice, very beautifully. And such a complicated system and model. Okay. So anyway, there are many, these are the basic of the induction motor. So you all can model just the first 2-3 model, that mass spring system, and send me maybe next week. And mass spring system, when you model, you will understand that how to write dynamical equation and how to develop Simulink model for this. Okay, with this we stop here, and we will continue from the next class with modeling of power converters. Okay, so first part you at least you try to do. Okay, so let us stop here. Okay, we will continue on Monday. Okay, so do you have any questions on this one? Saurabh?
Yes, sir.
You understood this one?
Yes, sir. When I'll design, then I'll ask
Yes, yes.
for
You at least this and this
spring
one
mode.
you do. The spring control part you do, and then once you understood the dynamic, any equation you have, you can design. Okay. So that spring part you do. Okay. I have very complicated presentation also. I don't think that it is required now because unless you cannot do a simple one, how this complicated system, although I have many things to speak, but you must do that much. Do you available? Do you have MATLAB or not in your computer?
So we can operate it online.
You can operate from this mass spring one you do, and these equations are available also. This just take a second order differential equation and try to model this. Okay, mass spring system, and then we will next class I will after completing the power converter modeling, I will send a IEEE paper and where you can easily implement that one and we will discuss. After that, we will go to facts and then I'll give the project. Okay? All right. So we stop here. Okay. Thank you very much.